So as I told you guys, in the coming lab, it's gonna be about rotate and shift instructions. Okay, and you are going to have a number. I don't remember 5 or 6 programs, but they are very short programs. Some of them are very interesting. Okay, I think all of them maybe are very interesting. So here I just want to maybe explain some ideas here just to make it easy for you. So for example here, as I already, when I explained shift instruction, guys, I told you shift left can be used to multiply by 2, right? So if I ask you to multiply by 8, what can you do? That's easy. I can shift 3 times, right? Because every time, for example, here when I shift 1 time, I multiply by 2. When I shift another time, I multiply again by 2. So total, I multiplied by 4, right? So if I ask you to multiply a number by 8 using shift instructions, it's very easy. All what you have to do, shift 3 times. Makes sense, right? However, in the lab, I asked you to multiply by 9. So how can you get 9? You got what I'm saying? So the way you have to do it is, you can shift 3 times to get 8. 8 times the original value of A. And then you have to add the original value back. You got what I'm saying? So this is, for example, assume the original value is number 1. Okay. If I shift after, so what you have to get 9A, it has to be number 9, right? So because 9 times 1 is 9. Okay. So after you shift it 3 times, I'm going to get number 8, and then I have to add the original value. So you have to save the original value somewhere, because you are going to use it later after you shift register. Is that make sense, right? In any question? Easy, right? Okay, so this should be one program. You have, after you program every program, you have to run it and make sure it's working, right? So how can you make sure it's working? You have to put some value here and multiply it by 8, and then see if the result is correct or not. However, you have to make sure there is no overflow. So when I put a certain number here, I have to make sure after I multiply by 9, the result, there is no overflow. Otherwise, if there is overflow, the result is not going to be correct. Okay, guys? So any question here? That's easy, right? Any questions? Great. So another also very interesting question, guys. In the lab, I asked you to do something like that, like rotate without carry, right? How this is different from what I taught, right? The difference is, what I taught before, the carry was in the loop here, right? So you have to put the carry here in the loop. What I'm asking you to do here is rotate, right, without carry. So there is no carry here. It's not in the loop, right? For sure, I don't have an instruction to do that. And as I said multiple times, if you don't have an instruction to do it, that doesn't mean you cannot do it. As I said multiple times, you can do it, but using multiple instructions. Okay. So as you see here, so after I rotate, B0 has to come here, B7 should come here, and B1 should come here, as you see here. Okay, guys. Again, how can we do this one? Easy. Oh, you can shift. Okay, so if you shift, use shift, you put here 0, right? And then the last one here is B0 goes to carry. And then after that, I have to write an instruction to copy the carry and put it here. How can we do that, right? You can see here, guys, all the bits are correct except this bit number 7 here. So look here, all of them are okay now except this one. So I have B0 has to come here. Okay, what it means? It means I have to copy the carry here, right? Very easy. All what you have to do, guys, you have to check the carry. I already explained in instruction before. How can you check the carry, guys? Branch if carry is clear, branch if the carry is set, right? It's very obvious, guys. If the carry is clear, if there is a 0 here, you don't need to do anything because you already put 0, right? You have to be smart, right? So if this one is already has 0, so I'm done. I don't need to do anything, right? However, if this one is set, is 1, right? So I have to set this bit. So the way you have to do it, guys, you have to use a branch instruction that can check the carry. In case if the carry is 1, is set, so you have to set this bit. I already explained several instructions or explained how can you set one bit in without changing the other bits in a byte, right? Is that clear, guys? Very interesting. Any questions? Yeah, I think the other ones are easy. Again, as I will see at the beginning of the lab. I will see if you have any problems. But again, what I'm telling you, I think I made it very clear in the lab. Every program, the programs are separate. So maybe this lab is different from the previous labs. You're not gonna write one program. No, it's not one, right? So every problem has its own program. Okay, guys. Any question, guys? Okay. Also, last time I explained the stack. I explained, guys, what is a stack. It's a memory, as you know. Last in, first output. The way we read or write is different from what we did before, because what we did before we call it random access, but this time it's last in, first output, right? Also, I explained this instruction here. We have push A, push B. Push means, as I said last time, guys, push means you write to the stack. If you want to write something to the stack, use push, right? If you want to read from the stack, use something, we call it pull, right? And also here, they said, I explain, okay, now, why stack is useful? It's very useful. The first or the main reason for having a stack, as I told you last time, guys, to be able to have functions or subroutines, okay? They mainly invented stack to help to implement or run functions or subroutine, as I'm going to elaborate right now, okay? But still you can use it for something else other than that, okay? So for example, number one, you can use it like temporary storage of data. I give you a very good example here. I explained it before. You have for loop here, and register A should store, or register A is storing the count, right? So now I want to use register A for some reason. So I should not lose this value, right? So all what you have to do, you can push A. So I'm going to store the value of A in stack, and then I can change A. And before I come here, when you decrement A, you can pull the value back from stack, right? So we're going to do this all the time. Also, you can, if you push A, also this is very interesting. Okay, try to learn it. You have to learn it, guys. Look here. If I push A, push B, okay? And then pull A, pull B, it's the same order, right? So A, B, it's the same order. If it is actually the same order, you are going to swap A and B, right? Why? Because last in, which is B, is going to be the first output is going to go to A, right? But if it is reverse order, so they are going to get the same value again. And I told you this is very useful in subroutines. For example, if you look here, guys, here I push A, push B, push X, push Y. This is all the time we are going to do this, guys. At the beginning of any subroutine, we put a number of push instructions this way: push A, push B, push X, push Y. And at the end, we pull them, but in reverse order, right? Why it is reverse? So that every register should get the original value back, right? I told you this is a very good programming habit, very important, because if you already put some value in the register here and you call the subroutine, your subroutine should not destroy these values. Otherwise, I want to use them later in my program, right? So to avoid making mistakes, if any register that you want to use in a subroutine, you have to store the initial value and then you have to get it back, so that in the main program, guys, any value here, if there is X is holding, for example, a pointer or any value, you are going to get the same value after the subroutine, okay? Because you need to use A and X, for example, here inside the subroutine. Okay, guys? I give you some examples for sure. I did that before. Also, I explained now, let me go. Yeah, I told you, yeah, here. I told you guys the way you are gonna do it, starting from we're gonna start for data as usual. We're gonna start from 1,000. For code as usual, we're gonna start from 4,000. For stack is gonna start from 4,000, and so that means, as I explained last time, when you start from 4,000, that means actually you are gonna it's going to be one less, right? Because when you push, you decrement stack pointer first, as I explained before. So your stack has to grow this way, okay? And I told you have to make sure there is, we already have enough space here for data and for stack. So there should be, you should not push too much to go to the data area, or you should not write too much data to go to the stack area, because you are going to make a mess in your program, right? I explained stack pointer, guys. So stack pointer is going to be updated automatically every time. Stack pointer should point at the top of the stack. This is where you read or write, okay? And then after that, I explained also subroutines functions. I explained why subroutines are good. Well, this is general for any programming language. Why you like subroutines? I told you, number one, without subroutine, if there is a certain code, you have to use it multiple times, so you have to repeat, right? For sure, if you repeat, your program is going to be too long. It's going to be difficult to read the program. It's going to take a large space in memory, right? However, if we use subroutines or function, you can just write it one time, and every time you need to execute this code, you call, you come back, right? That's what I explained as well. And most importantly, and this is very important thing, is reusability of codes. What does this mean? It means if I have a subroutine and I tested the subroutine and the subroutine is working very well, right? So I can just reuse in different programs. Not only that, I can even give it to someone else to use in his or her program, right? And that's what we're gonna do actually in chapter 3. In chapter 3, we have some subroutines. You can just include, for sure I'm gonna teach them in details, and then you can just include in your program. I'm quite sure the subroutines are working, right? And also here, I explained this one last time, guys. To make any subroutine for any programming language, right? To make a subroutine, we have to do 4 things. Number one, we need a way, we need a mechanism, we need a way to call the subroutine. So, for example, if I come here and, for example, we have a subroutine here, the name of the subroutine add can be any name. For example, I'll just give you an example, any name. And then here, there should be an instruction, a way to, once I come to this instruction, guys, I'm gonna call the subroutine. So I have to come to here to execute an instruction here, and then I have to return. When I return, I have to return the instruction after call, right? So I need 2 things. Number one, I need an instruction to call, right? How can you call, right? Also, we need an instruction to return. How can you return, right? How can you, after you finish the subroutine, you have to return to the instruction here, right after call, right? These 2, they are must. You have to do it, right? But sometimes you need to pass some data. Sometimes you need to return some data, right? Again, as I told you last time, it depends on the programming problem. Sometimes for the subroutine, I don't need to pass anything and I don't need to return anything, okay? Sometimes you need to pass, but you don't need to return. Sometimes you may return and you don't pass, and so on. So there are, it depends on the programming problem for sure, okay? So let's start with the first one, as I explained also last time. How can you call a subroutine? Very easy. All what you have to do, guys, we have BSR, branch to subroutine, or jump subroutine, right? And then you have to write the name of the subroutine. And this is just a name. I know sometimes, guys, you are confused when I use some names like keypad, or next, or when I use some names, you may think this is a command. No, it's just a name. But for sure, I have to select a correct or a proper name, good name for a subroutine, right? For example, if subroutine is doing addition, for sure I have to use word related to addition, right? Add, whatever. But I shouldn't use subtract, right? Otherwise, for the computer, it doesn't matter, right? But for us, I'm confusing myself when I read the code, right? So here, this is not a command, just a name for a subroutine, right? And I told you I have 2 instructions. One is called the branch subroutine. The other one is called jump subroutine. Jump subroutine is long, so I recommend to use it all the time. This one is short branch, so you can just use this one all the time, okay? To return back, we have only one instruction, guys. To return back, it's called RTS, right? So it's called return subroutine. This has to be the last instruction in a subroutine. So I give you an example here now, guys. So again, sometimes I want to remove confusion, guys. When I use call here, actually there is no, here I'm not teaching assembly. I'm saying here we need an instruction to call, right? But this is not an assembly instruction, okay? So also, this is not an assembly instruction. I'm telling you, we need instruction to call and we need instruction to return. Now, what is an instruction for call? This one. What is an instruction for return? This one, right? So don't be confused. Here, when I call first, this is that's what you have to do in your program. You have to write as a subroutine this way. You have to put colon, okay, and then when you call the subroutine, you just use a GSR, jump subroutine. You put the name of the subroutine it has to go, and then it's going to execute the instruction until it hits RTS. RTS is going to return it back to here. Is that okay? For sure, I told you about. Yeah, I think last time I explained. If you forget RTS, right? So what's going to happen? Remember, all these instructions are in memory, right? So after the subroutines, there are some bytes here, right? So there are some data here or bytes or whatever. So it's going to continue in the memory, right? It's going to continue in the memory. It's going to take whatever there here. If by accident whatever is stored here, okay, after this instruction in memory, whatever is stored here are in instruction, it is going to execute these instructions, okay? If it is not in instructions, a valid code for instruction is going to give you error, okay? So don't forget RTS here, otherwise it's not going to return back. Also, here, yeah, I told you this is how our program is going to look like from now on. We have a number of subroutines, as you see here. Everyone has to end with RTS, right? And then we have what we call the main program, okay? You have to do something here, otherwise, again, what's going to happen? This one is going to continue this way to the end, and this is going to continue because they are in memory, right? So after executing this instruction, if you don't do anything, it's going to come this way, right? That's why usually most of the time, again, it depends on the programming problem. If you want to repeat your program, and this is mostly the case, I think in many cases, we have to go to the beginning again. We'll use this one a lot. In some cases, maybe I need to do looping here this way. Otherwise, if you forget this one, guys, it's going to continue here in the memory, right? Okay. So usually, main program, we're going to do something like that or something like that, and then you can put your subroutines. Okay. Now I told you guys, without a stack, we cannot have subroutines, right? The hardware cannot execute subroutines if you don't have stacks. Why? I'm going to explain to you why now. Okay. So look how it works here, guys. For example, assume at the memory location 4007, we have this instruction, jump addition. Again, addition, just the name of the subroutine, it is right here, right? And then addition here, it is at location 5008. Just any names, just to explain the idea. So I just use, I just use any numbers to explain the idea. Okay. So what it means, what should happen here before I tell you how it happens? Let's first think what should happen here. What should happen, guys? After this instruction, after we execute the instruction at 4007, right? We have to come to 5008, right? To execute the starting from 5008, right? We have to do that. So this instruction has to send me to here, right? This number one. Number two, once I come to here, to RTS, I have to come to 4009, right? So 4009, a very important address, right? We call it the return address. This is where you have to return after you go to the subroutine. This is where you have to return, right? So how can I memorize this one? Because this one is needed here. RTS needs this one. I'm going to tell you how it works, guys. Look here. As I explained before, when we execute one instruction, where is PC? When you execute one instruction, PC is pointing at the next one, as I explained before. So listen to me. So when we execute this instruction, PC should hold this value, 4009. All right, makes sense. That's what I said very early, right, in this course. Every time you execute one instruction, PC is pointing at the next instruction, right? So PC is here, right? So how this, all what you have to do is just say jump, but I'm explaining to you how it works, right? How this jump should work. This jump actually it has to do two things, guys. Two things. Okay, automatically it has to do two things. Number one, it has to save PC somewhere. Why? Because PC is holding this address, what we call return address. I have to save it somewhere. Why you have to save it? Because I need it here. Makes sense? I need it here. So this instruction, number one, has to save PC. How where it has to save it in stack. So this instruction automatically is gonna push BC in the stack. It's number one, right? Number two, now we need to jump. We need to branch. Okay, how can we branch? I explained it before how we branch. All what we have to do, I'm gonna put this address in PC, right? So PC should equal this address so that next time I'm gonna come here. So I can say, guys, this instruction actually is doing two instructions I explained to you before. Number one, push. Number two, branch, because this is what branch is doing, and this is what push is doing. So it's like two instructions, but in one instruction. Okay, guys. So tell me true or false. Okay, think about what I'm gonna say right now, and then tell me true or false. Always at the beginning of any subroutine, the top of the stack is holding or is storing the return address. True or false? For sure, that's true, right? Because when I come to the subroutine, the jump instruction already pushed the PC to the top of the stack, right? So always at the beginning of any subroutine, the top of the stack is holding the return address, right? This is number one, guys. Number two, when I come to RTS, okay, this is important. Listen to me. Look, I'm writing it here. Always at the beginning of a subroutine, the top of the stack has the return address, where we are gonna come back, right? Number two, when I come to RTS is gonna take whatever on the top of the stack, put it in PC, so that I come back to here. You got what I'm saying? So now if I come here, guys, the top of the stack is 4009, which is this one, because this instruction jump is already stored PC, which holds this one, top of the stack. So when I come here, the top of the stack is holding the return address, right? This number one. Number two, when I come here, the top of the stack also should be 4009, because this one is gonna pull whatever on the top of the stack, put it in PC, so that I come back to here. Is that okay, guys? Okay, let's now make a mess. How can you make a mess? Okay, I'm gonna tell you how. Look here. Now, in the beginning of the subroutine, this is my return address. Okay, when I come here, if you want your program to work correctly, when I come here, the top of the stack also should be the return address. Makes sense, right? To work, right? Makes sense. However, you can push or pull here, right? So you can use the stack here. So you can push, pull, push, pull, push, pull. Okay. So again, these are machines. They don't understand, guys. If you push some value, and when you come here, the top of the stack is not the return address. Again, this one is gonna take whatever there, put it in PC, and then go to this location, right? So very important what I'm gonna say right now. Very, very important. To make sure your program is working, it's gonna work correctly, you have to make sure, okay, when you come here, the top of the stack is the return address. How can you make sure, right? This is, you have to make sure if you push 10 bytes, you have to pull 10 bytes as well, right? So here inside the subroutine, guys, you can use push and pull. Not only can, I'm saying we have to always use it, right? As I told you before. Yeah, here in the beginning of the subroutine, we push and pull. So we are gonna use the stack here. However, you have to make sure inside the subroutine, if you push the same amount of data you push, it has to be the same amount of data you pull, so that when you go to RTS, the top of the stack is return address. It's not something else, right? Again, what's going to happen is if you don't do that, your program is going to crash. It's not going to. Why? Because again, this one is going to take whatever on the top of the stack. So if you have a different number here, this one is going to take this different number. It's going to go somewhere in your memory. It's going to go somewhere in the memory, and then it's going to take whatever there. If it is by accident, the code there is for a valid machine code, is going to execute it, okay? Otherwise, it's going to give you error. It's going to tell you, because you are not going to come here to the program again. You are going to go to a random place in memory. You got what I'm saying? So let me tell you the conclusion of this slide before I leave it. before I leave this slide, let me tell you the conclusion. The conclusion is, guys, number one, jump subroutine, guys, here should, number one, push PC in stack. Why? Because I have to store the return address because I'm gonna need it later. This number one. Number two, in order to move from here to here, okay, so this instruction is gonna store the beginning address here, is gonna put it in PC. This number two, right? Number three, once I come here, RTS, so in the beginning of the subroutine, always the stack is storing the top of the stack is storing the return address, right? So if when you come to RTS, you have to make sure the top of the stack is still storing the return address, okay? Because this one is gonna take whatever on the top of the stack and put it in PC, right? So that I can come back here, okay? So very serious, very important, right? So here you have to make sure the amount of data you push should equal to amount of data you pull before you go to RTS. Otherwise, your program is gonna crash. It's not, you're not gonna return to this location. You are gonna go to a random location. Any question, guys? Very important, you should understand it. Any question? If you have any problem, just unmute and talk to me, okay? Okay. Now, look here, guys. It is possible, for sure, you know, from any programming language, you can make jump or you can call a function. This function can call another function. This function is going to call another function. This function is going to call another function, and so on, right? And then when I return, if this is the case, I'm going to jump from here to here, and then from here to here, from here to here, from here to here. Now, when I return, I have to return first from here to here, and then from here to here, and then from here to here, and then from here to here, right? It makes sense, right? How this can work, okay? Or let me say it in a different way. In this slide, I wanna convince you why they invented stack. Why they made the stack so that it can be lost in first output, right? Because this is exactly what I need here. That's why they made the stack lost in first output, because that's what I need here. Why? I'm gonna tell you why. Look here, guys. As I explained right now, when you call this function is gonna push. This is the stack here. This function is gonna push the return address, which is addressed here. I'm gonna call it RA1. It's gonna push it to stack, right? If I come to this function, this one here, this jump subroutine is gonna also push this return address to the stack. So now the stack has RA1, this one, and then RA2, right? And then I'm gonna come here. Also, this one is gonna push the return address to the stack, right? Which is RA3, right? Now this one's the same thing. This one is gonna push RA4 to the stack. So now the stack has the 4 addresses. This one, return address here, return address here, return address here, return address here. I have them, but the way I store it here, guys, is lost in first output. Why? Because when I return it back, I need this one first, last one first output, right? And then need this one, and then this one, and this one, right? That's why I created lost in first output. Okay. So what happens? This is a stack. When I come to this RTS is gonna take R4, okay, return address 4, which can bring me here, right? And then this now the stack looks like something like that, okay? Now the top of the stack is RE3, right? So once I come here, so this one is gonna return me to here, right? So now the stack has 2 values here. Once I come here, okay, so this one is gonna has the return come to here, right? And then I'm gonna come back to here. Is that clear, guys? I want to convince you here, guys, why they created the stack lost in first output so that it can work in this scenario, because that's what I need, right? Because I told you stack was mainly created just to enable subroutines, because without a stack we cannot make subroutines, right? Also, it has to be lost in first output so that the scenario that function can call a function, it can work. Any question, guys? Great. Now, the last thing I want to explain now, I told you, let me come back here. I told you guys, to create any subroutine, you need a way to call, right? A way to return. I already explained instruction here, two instruction, GSR and PSR. Okay, and here we have RTS. This is not an instruction. By the way, in some programming language, we use this one, RET, right? But here it's not in this processor, right? Here in this processor, we use RTS. Anyway, it's just the name of the instruction, right? So now I am done. I already explained how they work, right? Why the stack is the last in first output, right? Now I'm gonna move to the last 2 points, okay? If you wanna pass data, how can you pass data? If you wanna return the data, how can you return data, okay? Number one, here, if you wanna pass data or you wanna return the data, okay, let's do it. The very easy way to do it, okay, you can use register or memory locations, okay. For example, here I want to pass some value to this subroutine, okay. So I can put this value in register A, and this subroutine can take it from register A and then can use it, okay. Same thing for return. If you want to return something, you can return it in one register, or you can return it in memory location. So this looks like it's because registers or memory location are global. What it means, what you mean by global? I mean, register here is going to be the same register here, right? So memory location is going to be the same memory location here. So they can be like a global variable. Yeah, so you can just easily use this one just to pass some, the easy way, just you can pass some data, you can also return some data, okay? As you will see right now, I'm going to tell you, for example, I have a subroutine. In order to use this subroutine, you have to put some value in register X, for example, okay, and Y, for example. And then I'm going to tell you the result or the return value is going to be stored in register A or B and so on. So we can do it this way, right? For sure, you can do something like local variables, but in this case, you have to use a stack. And in this case, it may be a little bit more complicated. That's why, just to make it easy for now. So in this course, you can just use this one to make it easy. Okay. So here I give you one example, guys. I have here a subroutine. This subroutine, I'm going to call it addition, right? This subroutine should add to very simple subroutine. So here we want to add two number, okay, and we want to return the addition, right? So here this is the name of the subroutine, addition, okay. This subroutine should receive 2 bytes and should return the summation of the 2 bytes, okay. And the way I designed it is the 2 numbers you want to pass the subroutine, you should put them in register A and B. This is my selection, right? I selected them, okay? And then the result is going to come back to you in register A, right? So I designed the subroutine this way. I designed it so that you have to pass 2 numbers, one in register A and one in register B, and the subroutine is going to do some computation here to do addition, and then the return value is going to be in A. Okay, very important. Listen to me now. So how I can use the subroutine in this case, right? The way you have to use it, very simple. Before you call the subroutine, you have to put the numbers you want to add in register A and B, right? Because this subroutine is expecting 2 numbers, one in register A and one in register B, right? So before you call the subroutine, you have to put the 2 numbers you want to add in register A and B. And that's what I did here, guys, as you see. So here, for example, I'm going to put number 20. I'm going to put number. So I have to set the parameters or the register before I call the subroutine, right? And then after that, I'm going to call the subroutine. Once I call the subroutine, I'm going to come here. This subroutine is going to use this instruction, add register A plus B, and then it's going to store the result in A. And then after this instruction, I can use register A. Register A now has a summation of A and B, right? So anyway, this is just a very simple idea, a very simple program. I'm going to give you more examples for sure. Okay, any question, guys? Any questions? I need some question, guys. Okay. I think I explained this one before. I can repeat it quickly. Also, what we are going to do, guys, is, for example, here I have a subroutine. It is called F1. Any name, right? F1. So here I jump subroutine. So I'm going to come to here in this subroutine, right? And at the end, it has to be RTS. Okay. I told you before, guys, if this subroutine is using register X, Y, A, and B, for example, I'm just giving you an example. If it is using these registers, okay, guys, so you have to push them here and you have to pull them here. And it has to be, the order has to be in opposite order, right? So here, X, Y, A, B, here it has to be B, A, Y, X. Okay, why? So that in the main program, whatever in this register before and after should be the same. Okay. So you can do something like, again, look here, guys, please. You should not do that in the return register. You can, otherwise you did nothing. For example, if I'm telling you the return, I'm gonna return a value in register A, for example. Okay. So you should not push A and pull A, right? Otherwise, you are gonna return the same value back, right? So you have to do that. You have to do this push and pull instruction for all the registers except the registers that you are going to return some value in them. Otherwise, you are going to return the initial value back. Is that clear here, guys? Any questions? Good. Okay. Now, what is left in this chapter? Okay. Let me first tell you the good news. The good news is I'm not going to teach instructions anymore until the end of the semester. So I already finished teaching instructions. Okay. So what I'm going to do in the coming chapters, I'm going to use the instruction I taught in chapter 2, also some instruction in assembly, in C language, to program, you can say, some application. Okay, so I'm going to teach in next chapter how can you program LCD, how can you read switches, how can you program the buzzer. So the amount, or I'm not going to teach new programming ideas. So now the course will go in the direction of applications more than programming. Okay, and you will like it because it's going to be more interesting. Some students, I know some students don't like programming, but starting from next chapter, I'm not going to focus on programming. I'm going to use what I already taught in to program input output devices. Okay, so now what is left here in this chapter, I have two programs examples. So let me teach these two programs and then we're going to start chapter 3. Okay, so again, just in case you missed it, I said last time, and also I sent you email, guys, that the test 1 is going to be in March 25th. It's going to be the first Thursday after the break, right? So it should cover chapter 1 and chapter 2. Okay. So now let's see what this program is about. In this program, we want to make what we call lookup table. So what you mean by lookup table? Okay, it's a very interesting programming tool. Sometimes we use it. It's very interesting. So table here means array, no difference, but just we use the word table. So it's called lookup table. So what is the idea here? I'm going to tell you what is the idea. Look here, guys. Sometimes if you wanna calculate sign or log or any other functions that may take much computation, and your processor may not have too much computation to calculate these functions. Okay, so what can we do in this case? So let me explain it again, guys. What I'm saying is I have a certain functions like sine, cosine, whatever, and maybe to calculate this function, maybe it's going to take some time, and the processor is going to take some time. So what can we do? I'm going to tell you what can we do. We can do something, we call it lookup table. So what it means? It means I'm going to store pre-computed values. For example, if you want to get sine 10, I'm going to store the value. If you want to get sine 20, so I'm going to create a table. This table should have the results of some values, right? For sure, if you have too many values, it may be too long. Yes. So here I'm gonna. The good thing is going to be less computation, because actually you are not going to do the computation, right? So you are going to store the results. I'm gonna store the results in a table, right? So I'm not gonna the microprocessor is not gonna do the computation, which is good, right? However, I have memory. I have to take more memory, right? Because I have to store the table in the memory. So now here I want to give you one example about. So this is the idea. If you look up table, just in case you hear the word lookup table, you already should know what is lookup table, why you need it, and now I'm going to explain how can we use it. Okay. So what I want to do right now is I want to give you example. If we want to create a lookup table for a square value, right? So how can we make it? How can we make this table? Also, how can we use it in programming? How I'm going to tell you how very easy. You will see right now how I create it. Look here, guys. So this is an array. I'm going to assume X is pointing at the first location in the array. Okay, again, don't be confused. Table here means array. It's the same thing. Okay. So X is pointing at the first location in the array. Okay. So as usually we do for sure. Okay, so I need a pointer this way. X is pointing at the first location. Okay, so X plus 0 in this memory address, X plus 0, I'm gonna store the square of 0. X plus 1, next address, which is X plus 1. Again, X is holding the first location, right? So the first location is here, plus 1 is gonna be here, right? So in X plus 1, right, or in the first location plus 1, I'm gonna store the square of 1. In number 2, I'm going to store the square of 2, right, which is 4. In number 3, I'm going to store the square of 3, which is 9. In the last one here, 15, right? In 15, I'm going to store the square of 15, which is 225, right? 16, so someone can tell me why your maximum is 15, right? Because if you look at 16, it's going to be more than 255, right? Because here I'm assuming I need to store bytes, right? So for sure you can make it for word. It's the same idea. You can use the same idea for words, but here I'm assuming I just want to store number from 0 to 15, right? That's why only I need bytes, because until 15 we have 225, which is enough for a byte, right? More than, if you use 16, right, it's going to be more than 255, so you need a word, right? So now look here, look, the way I did it is I did it in a very smart way, right? So that when I make it very easy. When you get any value, you are going to get very easy. I'm going to tell you, look how I made it. X plus a value is going to give you the square of the value, right? So X plus 15, you get the square of 15. X plus 1, you get the square of 1, and so on, right? So if you need the square of 7, what should I do? Where is the location of the square of 7? It's going to be X plus 7. That's easy, right? So X plus 7, how I can make X plus 7? I can make something like that, A comma X, right? This is, and then you can put the number you want to square, put it in A, right? Remember, this was one of the memory, the ways we can pointers for memory. It can be register A or B, comma X or Y, right? I explained this one before. So if you use this one A comma X, that means this is a memory location at X plus A. Is that okay, guys? So as you will, number one, you should understand, I arranged it this way so that I make it easy to get the square of any value, right? So if I store in X the beginning address, right, and then I put in A, any number I put it in A, so the location A comma X is going to give you the square, the square value of this number. You got what I'm saying? As you see here. So 0 comma X is going to give you the square of 0. 7 comma X is going to give you the square of 7, right? So yeah, so I made it this way. So you will see right now how I'm going to use it, right? So now I'm going to create a function, right, or subroutine. This function, you can pass a value in register A, right? And then this function should return the square of this value in register A as well, okay, as you will see right now. Look how it works, okay? So the way it works is, here I created a subroutine. I'm gonna call it square. Again, just a name. You can call it any name, right? You can call it square. And then, as I told you, I'm assuming this subroutine can be used for a number from 0 to 15. Okay. So if you send any value outside, if you send value a number in register A that's greater than 15, there should be error, right? Because this function can only be used from 0 to 15. So you should not, or the user should not send the value greater than 15. But in case this happens, so I need to catch this error, right? That's what you will see right now. So look here, guys. So in order to use this subroutine, all what you have to do, guys, you have to put a number in register A, right? This number has to be from 0 to 15, and then call the subroutine. After you call the subroutine, now register A should hold or should store the square of the number you sent here. Okay, this is how can you use it, right? Is that okay? So before you call the subroutine, guys, you have to put a number. It's a number you want to square, put it in A, and then you call the subroutine, and then after that you can use register A. That now register A should store the square of the number you sent. Okay, guys, any question? Okay. Now because I want to catch error in case you send the number bigger than 15, right? So that means there is an error. To tell you there is error, so I'm gonna store in register A number FF. You got what I'm saying? So if register A has FF, right? FF is not one of these numbers here. Okay. So if you find it FF, so that means it is error. Okay. That means, for example, after you call the subroutine, I can check if A has a value FF or not, right? If it does not have FF, if register A stores FF, that means there is error. So you can come somewhere, as you see here, to display error. Okay, this is just a simple program, guys. But in reality, maybe this number is coming from the user. For example, you ask the user, they give you a number from 0 to 15, but the user gives you 20, for example. Okay, so in this case, you need to catch this error. So the way I'm gonna do it, I'm gonna call the subroutine. After I get a number from the user, I'm going to put it in register A, and then I'm going to call the subroutine. Okay? And then after that, I have to compare A to FF. If it is equal to FF, that means I have to come here to display error message. I'm going to tell the user, please try again, and this time give me a number from 0 to 15. Okay. Otherwise, if it is not FF, it means it's already register A is storing the square, and I can use it here. Okay, guys. So now I'm going to explain. Two things here very important, guys. Two things are very important. Number one, if I give you subroutine, can you use it? This is number one, right? Number two, how can you program the subroutine, right? So for example, I give you subroutine. I'm telling you the way you have to use this subroutine is you have to pass a value in register A. The score should be in A, and if A is holding FF, that means there is error. So how can we use it? Yeah, as I explained here. So you have to put some value in A, right? Later, this value, as I told you, it can come from the keypad, this value, okay? And then here, you call the subroutine, and then you can check the return value if it is correct or not, okay? Now, let's see how the subroutine works here, guys. Look, very easy. So now here in the subroutine, I'm expecting a value in register A, right? So here, I'm going to compare this value to 15. I'm going to compare this number to 15, right? If it is higher than 15, it is more than 15. What it means? It means it is wrong. There is a mistake. I asked you to give me a value from 0 to 15. You give me a number greater than 15. That means I have to tell the function that called me that there is error. How? By storing this number FF in register A. That's what I did here. Look here, guys. I'm going to compare A with 15, right? If it is higher, so I'm going to go to a location. I call it too big, right? So I'm going to come here, as you see here, location too big. And then after that, I'm going to store FF, and then I'm going to return. Is that okay? So FF means it's error, right? If it is not, if your number is not greater than 15, so this branch should not be taken. I have to come this way, as look here. So again, if A greater than 15, I'm gonna come this way, right? If A is less than or equal 15, I'm gonna come this way. Is that okay? Okay. If you come this way, what should I do? What I have to do, I have to get the square of A and to store it in register A. So how can you get the square of register A? A, X, right? So look how I admit it. Number one, X should store the beginning address. Okay, so load X with this one. So X is storing the beginning address. Okay, A is holding or is storing the number I want to square. Now, X is the beginning address. A is actually the number I want to square. So all what I have to do, I have to read this location to give you the square value. That's what I did. Look here, guys. Load register A with the value A comma X, right? Because A comma X is actually the beginning address plus the value of A, right? Which this should be the address of the square of A. So I'm going to get this byte. I'm going to store it in register A. Okay. Now I am done. So I'm going to come here to branch to come here. Is that okay, guys? There are two instructions I didn't explain here, guys. Push X and pull X, right? That is because here I'm going to use register X. Again, as I said before, your subroutine should not mess up with the main function, right? So any register here, any register you are going to use, you have to return the initial value back, right? So here I'm going to use X, so I have to return it back, except the registers that are storing the return address. So here I shouldn't do that for A, right? It doesn't make sense to return the initial value in A again, right? Doesn't make sense. So A should store the results. That's why I did it for X. I didn't do it for A. Please, guys, if you have any question, unmute and talk to me. Okay? Any question, guys?
Professor?
Yeah, sure.
So the branch and the jump instructions to go to the subroutine take care of the counter, the PC?
Yes. So this instruction, what I explained before, I'm just explaining how it works, right? So this instruction actually has to do two things, right? Number one, push PC, right? Because PC is all, when I execute this instruction, PC is here, right? So I need this address here, right? So this instruction is going to push the value of PC. This is number one. Number two, this one is going to take the beginning address and put it in PC, so that next time I'm going to jump it to here, right? And here now, in the very beginning, the beginning of the stack is the return address, right? I'm going to push value, and then I'm going to put the value back. So now when I come to RTS, the beginning of the subroutine is return address. So RTS is going to take whatever in the stack, put it in BC so that I can come here. You got it, or still it's not clear?
Yes, sir. Thank you.
So you don't need to push, or you put, this is what this instruction is going to do. This one is going to push, it's going to save the return address in stack, right? And also it's going to put the beginning address here in PC so that we can jump to here, right? Great. Any other question, guys? Okay, let's have another program before we finish this chapter. The last program here, guys, look here. I want to write a subroutine that returns if two strings are identical. Otherwise, it returns 0, 0, right? Let me say it again. I have a subroutine. I'm gonna send two strings. String here means a message or a string, right? So I'm gonna send two strings to the subroutine, right? And subroutine should check if these two strings are identical or not. If they are identical, so it has to return if. I think in register in memory locate again. It's up to you. You can return. You can decide. I want to put the return value in register A or B, or you can memory location. Here I decided for some reason. I just decided, this was my choice. I decided to return the value in the memory location. For example, 1200, 1200, right? So the return value will be here. Okay. So all what you have to do, guys, is I'm gonna send. I have to send two strings to the subroutine. The subroutine is gonna check, and then it's gonna put some value here, either 0, 0 or FF, right? Then after I return from the subroutine, I have to check this one to know if they are identical or not, right? So there are two things here. Number one, how you will pass a string, or how can you pass the strings? The way you are going to pass the strings, as you see here, guys, for string 1, I'm gonna put the beginning address in X. For string 2, I'm gonna put the beginning address in Y, right? So subroutine, the subroutine is gonna start from X, it's gonna start from Y to check if they are same identical or not, right? And then once it finds 0, that means it is delimiter, right? So here we use delimiter, guys. That's it. So let me say it in a different way. Number 1, I have two strings. You have to put 0 in the end of each as a delimiter for each string number. Okay. Then before you call the subroutine, you have to store the beginning address here in X. You have to store the beginning address in Y. So subroutine is gonna start from X, and Y is gonna check element by element. Look how it works, right? Element by element. So this element is equal to this element. Yeah, we are good. So increment Y, increment X. So it's gonna check element by element, right? And then it's gonna check if these two strings are identical or not, and then it's gonna return 0 or FF, right, in this memory location. Okay. So two things here, guys. Number 1, if I give you this subroutine, right, how can we use it? This is also very important thing. Number 2, how can you program the subroutine? Now, forget the programming now. I give you a subroutine. I'm telling you this information, right? So how can we use this subroutine? I'm going to tell you how. I'm going to focus on this one first, and then I'm going to focus on how can you program it. So let's first focus on how can we use it, right? So look here, guys. Number 1, I have two strings, as you see here. I just use the word string 1, string 2. Again, this is just a name. You can use any name here. So string 1 is string 2. Okay. For example, here I use FCC as we did before. I like ECE 3130, right? And 00. You can see here, guys. So what I did here, and here is actually we have array of bytes, right? As I said before, array of bytes, and then you put 0 at the end, right? That's exactly what I did. Because this 0, as I explained before, it's outside the quotation. So you're going to store number 0 because of delimiter. And I told you guys before, we like number 0 because 0 is not an ASCII for any character. So it's not going to happen to have any character here that has ASCII, that has this delimiter, right? Because I told you before, the delimiter should not happen here. Otherwise, if this delimiter is repeated here, so we're going to stop. Once we find the delimiter, we're going to stop. That's why when I select a number, as we did in the last lab, I have to select a number and make sure this number is not, I'm not going to use it, okay? In case of ASCII code, 0, we like to use 0 because 0 is not going to happen here, okay? So because there is no ASCII to a character with 0, right? Is that clear, guys? Any question here? So now I have two strings. I define them this way, right? It's like, as I said before, it's array of bytes. And here you store the ASCII code, you put 0, right? This is number 1. Number 2, as I told you, now when you already forget the subroutine, you already have the subroutine, right? So now focus on how can we use it? How can we use the subroutine? Look here, guys. All what I have to do is just jump a subroutine, right? So I can say jump. I just use this is the name of the subroutine. It check underscore strings, right? So you can just jump to the subroutine, as I said before. However, before you call this subroutine, okay, this subroutine is expecting two values in X and Y, right? So I have to put this subroutine is expecting the beginning address of this one and this one. So that's what I did. Look here, guys. So here I put the beginning address in X, the beginning address in Y, because this is the data I have to pass. This is the data I have to pass to the subroutine. So I put the beginning address in X, the beginning address I put it here in Y, and then I'm gonna call the subroutine, right? So subroutine is gonna start from X, start from Y, as I said before, start from here, it's gonna check it until it finds 0, and then it's gonna give you the decision. It's gonna give you the result, either 0, 0 or FF in register, in memory location 1200, right? You can, again, this you can programming, you can just put it instead of a memory location, you can put it in a register, okay? Anyway, and maybe it's, honestly, it may be more professional to put it in a register rather than memory location, but it's very easy, we can do it, right? So here, then after I call the subroutine, guys, now I need to know if the two strings are identical or not. So the way you have to do it, you have to check if this one has 00 or FF. Okay, guys. Very interesting. You know why very interesting? I'm going to tell you why. Look here, guys. I can use subroutines without even caring about the details of the subroutines. For example, I give you a subroutine like this one. I'm telling you, don't you don't worry about the content of the subroutine. Just put the initial value here, put the initial value, call the subroutine, and then you can solve the problem. You can know if they are identical or not, right? And that's what we're going to do in the coming chapter. For sure, I'm going to explain everything, even the content of the subroutines. Okay. However, this just I give you one very interesting or why using subroutines is very interesting. Because I told you I can just give you one subroutine and then you can just use it, right? Something like that. So two things here, guys, very important. Number one, if I give you subroutine, can you use it? That's what I explained here, right? And how can you use it? Number two, how can you program the subroutines? That's what I'm going to explain right now. Okay, guys. Any question before? Any question on the use of the subroutine? So I already give you subroutine. I am telling you that you have to pass one value here, one value here. That's why before you call the subroutine, you have to pass and pass, right? Also, I'm telling you the return will be in register A or in memory location, whatever. And then after that, you can check to know if they are identical or not. This is how can you use. Any question, any problem here before I explain how can you program this subroutine? Okay. So now how? Okay, now how can you program the subroutine here? I'm going to tell you how. Look, very easy. I'm going to tell you how. Look here, guys. The idea. The idea is this string. If they are identical, it means this element is similar to this element, right? This element is equal to this element. This element is equal to this element. This element equal to this element, and this element is equal to this element, and both are zeros, right? If this is the case, they are identical. However, so I have to compare element by element, right? So x is 0, y is 0. So I need to make iterations, right? So I have to make iteration. In the first iteration, I'm going to compare element to element, right? And then element to element. Every time I have to increment x, increment y, right? Because in one iteration, I'm going to work on this element and this element. In next iteration, I have to increment y, increment x, increment y, increment x, this way. Okay, guys? Until I find zeros. Once I find zero, I'm done, right? So what I'm saying, if I find one element here, two cases here, guys, listen to me, two cases. One case, when I compare element by element, if I find one element here that does not equal the element here, okay? So what it means I don't need to continue because the two strings are not identical. Make sense? Makes sense, right? So here, two strings are identical if all elements are similar, identical, right? So for sure they should have the same length as well, right? Anyway, so every element here is equal to the element. If I can find one element that does not equal this element, what should I do? Just leave. I'm done, right? So they are not equal, right? Anyway, that's what I did here. Look how I did it, guys. Number one, guys, I want to compare byte in memory to byte to memory. Do you have an instruction to compare byte to memory to byte to memory? No, we don't, right? So I have to take this one in a register. I have to take this one in a register, and that's what I did. So look what I did here, guys. Number one, I'm gonna read a byte pointed by X. Okay, put it in A, and then I'm gonna read a byte element pointed by Y, put it in B. So now I put one element in A, the other element in B, and also increment X, increment Y, right? Again, I told you this is a compact version, so you can, if you want to use this tool instruction, I'm okay. If you want to use this one, also I'm okay. Both are the same, right? So here I'm gonna read one element. I'm gonna read one element pointed by X, put it in register A. I'm gonna read this element, put it in register B, and also increment X, increment Y, just to prepare for next time, right? And now I'm gonna work on A and B, right? So look here, guys. So one element is in A, one element in B. Now I'm going to compare B to A, right? If I compare and if they are not equal, what it means? So that means I found one element that's not equal. That means I don't need to continue, right? So that means I'm done. So the two strings are not equal. That's what I did. So now I'm gonna say if they are not equal, if A and B are not equal, just come to here, not identical. When I come to non-identical, guys, as you see here, I'm gonna put 0 0 in 1200, and then I can two things now here. I can branch to end to come here and to hit RTS to leave because I'm done, right? Or you can just write RTS here, right? Again, some students may be a little bit confused here. Why? Because subroutine has two RTS. That's okay because I'm not going to hit both of them at the same time. I can hit this one or hit this one. You can do this way, or you can do branch. If you are confused, you can just do branch here. Okay, so let me say it again, guys. So now I'm going to compare the two elements. If they are not equal, right? So I'm going to come here to here. What should I do here, guys? Okay, already I made my decision. I made the decision. What is the decision? The two strings are not identical. So I'm going to put here 0 0 in this byte, right? And then now I have to return. So you can just write RTS here, right? You can do that. Once I hit RTS, I'm going to leave, right? Or you can say branch to end to come here so that you RTS and leave. I'm done. Okay. Now, if they are equal, if A is equal to B, if they are equal, okay. Now, there are one of two cases. If one element is equal to the other element, right? Now there are two cases. One case, if they are equal but they are not 0. So what should I do? I have to continue looping because I'm not done yet, right? So this element is equal to this element, but they are not 0. Okay, so I have to loop again. I have to go to next element, and repeat again, right? But if they are equal and they are 0, that means everything before was equal, and now I found one element is equal. These two elements are 0 and 0. That means they are identical. You got what I'm saying? So I checked here. They are equal, and now it's equal and 0. Okay, that means they are the same, right? That's what I did. Look here, guys. Now I am sure they are equal. So once I come here, because if they are not equal, I would jump into here. If I come here, that means I am sure the two elements A and B are equal, right? Because they are equal, now I'm going to compare A. Now I want to see if they are 0 or not, as I told you. If they are not 0, that means I have to keep looping and repeat again, right? I have to keep looping because I didn't reach to the end of the array yet. So I have to keep looping. Otherwise, if they are equal to 0, what it means? It means I'm done and they are identical, right? That's what I did. So now I'm going to compare A is equal to B. So if you compare A or B, doesn't matter. They are equal, right? So if you compare A to 0, right? If they are equal, what it means? I'm going to come to here to identical. Here in identical, I'm gonna store FF just to tell you they are identical. If not, if A is equal to B, but they are not equal to 0, what it means, as I told you, it means I'm still here. I didn't reach to the end yet, so I have to go back here and repeat again. Okay, guys. So let me say it again, and then I'm going to see if you have any questions. Number one, guys, look here. Number one, I want to compare memory location to memory location. We don't have an instruction to do that, so directly. So the way I'm going to do it, as you see here, guys, I'm gonna read a byte pointed by X, byte pointed by Y. I'm gonna put this one in register A. I'm gonna put this one in register B. So now the two elements, one in A, one in B, right? Also, I'm gonna increment X, increment Y for next iteration. Okay, to work on the next element next time. Okay, so now we have one element in A, one element in B. I'm gonna compare them. If they are not equal, so I'm done. Because the two strings are not identical. Because if you only find one element here doesn't equal one element here, that means they are not identical. That's what I did here. So if they are not equal, so I'm gonna come here non-identical to put the number 0 0 because 0 0 means it's not identical, right? And then return. I'm done, right? Otherwise, now if they are equal, in case of equal, there are two cases, right? One case, if it is equal to 0, yes, they are equal and 0. That means I finished. Everything was equal until I reach it to 0, right? Otherwise, if you can find only two elements that are not equal, I would leave, right? So to come to here, that means everything was equal, and now I'm done. I reach it to 0. So So now they are equal and they are 0. So now I'm going to go to identical to put FF to tell the function, the main function here is that they are identical. Otherwise, so if they are equal, okay, that means, and they are not 0. So I didn't reach to the end yet. So I have to keep looping. So I have to come back here. Okay, guys. So if you look at this code, guys, you can see we have infinite loop here. This part from here to here, we have infinite loop. The only way is to get out. This one can get you out. Also, this one can get you out, right? So the only way to get out of this infinite loop is to find two elements that are not identical so that you can get out, right? Or you can find the two elements are equal to 0. That means you already reach it to the end. In this case, I'm done. I'm gonna go outside. Other than that, okay. So I'm gonna keep looping. Okay, guys. Any question, guys? Okay. Last call, last chance. Any questions? Okay. So now we are done chapter 2. I promise chapter 3 will be more interesting. To me, chapter 2 is the most difficult to teach because starting from chapter, you will like it. It's more interesting. Because now we are going to use input-output devices. Now you will see applications more than programming. Okay, guys. So let's start chapter 3. What this chapter is about? What chapter 3 is about? Pretty easy. Chapter 3, guys, it's about interfacing to a microprocessor. So in this chapter, if you look at the board here, this is the board, guys, the Dragon board. And as I told you guys, starting from tomorrow, you should not use simulation anymore because starting from next lab, you have to use the board because we're going to start using input-output device. Anyway, so what I'm saying here, guys, if you look at this board, guys, for sure you know this is our microprocessor is here under this breadboard. Anyway, so our processor is here, and this processor is connected to input-output devices. So we have here a number of input-output devices like the LCD. This is the LCD, guys. We have 4 7-segment displays. We have 8 LEDs, right? We have switches. These are switches. We have push buttons here, right? We have a buzzer. This one can make some sound. Very, very interesting. I'm going to teach how can we make the police siren. Very alarm or police siren, whatever you want to call it. So interesting. So this is a buzzer. I'm going to teach all of that in this chapter. Also, we have what else I'm going to teach? We have a keypad here, right? So this is a keypad. I'm going to teach how can you use this keypad, how can you program it, right? Also, we have a relay here. I'm going to teach what is a relay. This one is very interesting. This one is called RGB LED. RGB LED. R is for red, G for green, B for blue. Because this one you can turn it red, you can turn it green, you can turn it blue, right? So I'm going to teach how can you program it as well. So this chapter is actually, all this chapter is about, guys, how can you program these input-output devices, okay? So that means how can you write some value here? How can you turn the LED on or off? How can you read the switch here to know if it is connected or disconnected? How can you know if the user is pushing the button or not? How can you make some sound here, right? And so on. So this is what this chapter is about. Very interesting. As I told you, I'm not gonna teach new instruction anymore. Old instruction I taught in chapter 2, I'm gonna use them here in something like applications. Okay. So let's go here. If you look, this is the processor, guys. This is our microprocessor here. This is our microprocessor. So if you look here, guys, you can see we have what we call port. Okay, this is similar. The word port, we use it, right? So USB port. Okay, if you want to connect any input or output device, you have to connect it to a port. Same thing here. So this is the microcontroller, guys. This microcontroller has a number of ports, as you see here. Okay, so in order to connect any output devices, you have to connect it to a certain port. Okay, and I'm going to tell you when, for example, here, port B. as you see here, port B. In port B, we connect the LEDs. So I'm gonna, sorry, let me come here. So here in this board, guys, there are some connection, but for sure you cannot see it. So there are some. This is the processor is here. This processor is connected to all these input-output devices, right? So there are some connections here. Okay. So, but what I'm saying very easy. What I'm saying is, we have a number of input and output devices, right? So, and any input output device has to be connected, or you have to connect it to a port, right? So that's what we do when you connect your mouse or you connect your keyboard. You have to connect it to a port, right? So first of all, let me so here I want to just show you what ports we have, right? So you can see here, guys, we have, oh, sorry, we have port B. As I'm going to tell you later, this is where we have 8 bits in port B. You can see here PB0, PB1, 2, 3, 4, 5, 6, 7. Okay, so 8 bits port B. We are going to use port B, as I'm going to explain later, to connect the LEDs, right? We have port H. Look, port H. This is H here. So this is PH0, PH1, 2, 3, 4, 5, 6, 7. So we have 8 bits for port H. Port H, this is where we connect the switches. Switches are connected here. We have port A, right? So we have 8 bits here for port A, PA0 until PA7. So this is where we connect the keypad. So the keypad is connected here, guys. Okay. Port T. So I have here port T as well. BT5, yeah, BT5 here. This is where we connect the buzzer. So anyway, anything I'm gonna explain, guys, I'm gonna tell you where it is connected, right? So port K, we use port K here. So I have PK0, PK1, 2, 3, and then we have here 4 and 5. I think it's only 6. No, we have 7 here, so it's 7. Okay, but port K, we're gonna use port K, guys, to connect the LCD. Anyway, I'm gonna teach you. But anyway, what you should understand now, guys, number one, we have input-output devices. This is number one. Number two, to connect any output device, it has to be connected to a port. In this case, it's already wired here. So if you here, there are some wires, right? So we don't have selection. I'm just gonna teach where they are connected. This one, but it's already wired here. Okay? So let me see. I think I have here. Okay, so here, okay, so just give me, yeah, here. Okay, so guys, here I told you we have input-output devices. So what do you mean by input or output device? I'm gonna make it easy. Look here, guys. Any device, if the microprocessor is gonna write to this device, we call it output device. So for example, if you read data from this device, we call it input device. Okay, so you should know what is input and what is output. For example, in this case, what is output here? Output is the LCD, because the microprocessor is gonna write some data to the LCD so that you can see it here, right? 7 segment also is output device, because you have to write. So the data has to go from microprocessor to here. You have to write, right? So that's what we call output device. If you read, like for example, here is this switch. You need to read the switches to know which one is connected. Same thing here for the keypad. These are input device. Okay. So again, if microprocessor is going to take data from this device, it's going to take data from this device. So this device is input. If microprocessor is going to send data to this device is output. Okay, guys. Let me tell you, we have here a table. Okay, yeah. We have a table with all the available ports here. Sorry. Yeah, so I told you we have port A, we have port B. Port A should have 8 pins, right? We have B, we have E, we have H, we have J, and so on. These all the ports we have, right? There are some ports, but they are in a different family. As I told you before, our microcontroller is in family D, right? But there are some other families that have other ports, so we don't have these ports, okay? Yeah, I told you here, any any input has to be connected to a port, any output has to be connected to a port. Okay. Later I'm gonna give you some details what I mean by port, or what port, what do you mean by port? Port is a circuit. I'm gonna tell you how so this circuit, that's what we call a port. As you see, look here guys, we have what we call input port or output port. So this circuit, and this is the internal system. This is internal system. We have RAM, we have ROM, processor, right? We have buses. You remember buses? Data bus, control bus, address bus, right? So in order to connect this device to the system, there should be a circuit, as you see here. So this is a device. This device should be connected to a port so that it can be connected to a system, the rest of the system, connected to the buses so that it can send data or receive data. Okay. The other thing here, guys. So I told you we have a number. Here I told you we have a number of ports, as I explained here. I'm going to tell you something very interesting here. So I didn't tell you. I just here I'm telling you here we have port A, B, whatever. So these are the ports we have on the chip. But I didn't tell you which port is input and which ports are output, right? That is because, as I'm going to explain next time, they give us flexibility. That means you can program any port here, input or output. You got what I'm saying? Why they do that? So any port here can be input or output, but you have to program it. You have to write some code to make it input or output. You got what I'm saying? Why? They give us flexibility, because if you want to make a project, this project needs a lot of input, you can make all of them input. If you need a lot of output, you can make all of them output. So they give us so conclusion, because it's already we finished the lecture. Conclusion, we have a number of ports, guys, as I'm going to explain next time. Every port you have to configure, you have to program it, input or output, right? Input device has to be connected to input port. Output device has to be connected to output port. Anyway, I'm going to explain it next time. Any question, guys, here? Okay. See you tomorrow.